I think it says I'm recording.
Oh, there we go. Cool. So welcome everyone to first intro to CAD. So for those of you who don't have it installed, and it's going to take a little bit to actually get Solidworks installed. That's weird. That would have been bad. You can go to that link and follow like the Solidworks install guide, and you can get it on your computer. It's not a lengthy process. It'll probably take like 30 minutes depending on how good your Wi-Fi is. But for now, you can just follow along with what we're doing, and we will be able to get you on it at a later point. Also, if you are on the HPRC SharePoint, you have it installed, all of those files are in the software folder, so you don't have to download it. You can just make a copy of this folder and hit setup. That's also true. You have to be on like the VPN and everything, so I don't know if you want to get it set up right now, but it's there. I have nice screenshots for everything we're going to do, so I'll also send out this presentation after. But we'll start with actually getting into SolidWorks. So the first time you open it, you'll be greeted with this screen. And this is a screen that'll show up whenever you open it. So on this screen, not a whole lot to say, but usually you just want to start by creating a part, which you can do here. You can also create assemblies and drawings in the same fashion or open existing parts. So if you're going to follow along at home right now, if you have SolidWorks open up, you can just come in and create a part. And that'll load up. So what we're greeted with here is your general SolidWorks window. Oh, I guess the other thing is if it's your first time setting up SolidWorks, you might get a dialog that asks you like what settings you want to use for your default template. If it asks you for that, you want to go for an ANSI drafting standard and IPS or inch/pound/second units, because that's what we'll be using on the team. And if you need to change it, it's pretty simple. You can just go down here and choose whatever units you want. So once you're actually in SolidWorks, there are a couple of things, and I put transitions on this, but I'm not presenting, so I can click easier, so you don't get to see them. But the first big thing that you'll see is big by window. That's the graphics area. That is where all the parts that you draw and stuff will actually show up. You'll be able to rotate it around, look at it, etc., etc. Next, in the most important things is the command manager. So we'll talk about that a little bit, but it's where all the commands are. The design tree is on the left. So that contains a history of all the stuff you do with whatever part you're making. Heads up toolbar has some quick information. So like this one lets you change lets you do a section view, which is useful if you get into complex assemblies. You can change like the background on that one. And the task pane is trash and completely useless. And all it does is show up every time you try and like open a new thing, just close it. You rarely have to use it. So as I said, the command manager up at the top contains pretty much everything you'll need to actually create your parts. And it has a whole bunch of tools that you can add to and remove from as you need it. So default, you'll start on the features tab. That contains your extrusions, your revolves, all these stuff, which once you actually have a part will be available. Sketch, same kind of thing. It'll let you do your sketch. We'll talk about sketches later today. And there are a whole bunch of other ones. Markup is one of the less useful ones. You can probably get rid of it. Evaluate, that lets you measure stuff, is really useful. So you can like see how long a line is or the distance between 2 points. Mass properties, which we don't have a part yet, but that'll show up there. Good for actually figuring out the weight of the part is. Other stuff, dimensioning, this is for more like drawings. Add-ins will let you, photo view will let you do renders, simulation will let you do FEA analysis. Those are both pretty useful. And you'll commonly pull those up depending on what you're working on. But yeah, if you ever need to use a command, it's probably going to be up in the command window, command bar. If it's not, you can come up here to the search bar and search it up. So something that I do regularly is the combine tool, which I don't even know where it is in the command bar, but search up combine, it's there. Equations, also not in the command bar, but that's useful for more advanced things. That'll probably be something for the second half of this workshop series, but that's the command manager. The other important one is the design tree. So it's literally just a list of everything that you've done on your part. So I'm going to open one. So once you'll actually have features that you've made, they'll all show up here. This is great because you can go back to previous spots. Let's say I wanted to change this and make an edit to it. I can just come right back to here. I can insert new features right after this, and then when I bring it forward, it's going to fail. But when you could technically do it, you'll also use the design tree a lot when you're working on parts. So that's a basic introduction to the SolidWorks UI, and you'll get more comfortable with it as you make parts. Just to start off, you really only need to know a few things, like the extrude tool is going to be your friend. And once we get some features in here, you'll see how to use the design tree effectively. But having said that, if there aren't any questions about it, we can get into actually making our first part, which really just involves a quick discussion of the workflow of most CAD softwares. This isn't universal, but all the ones most people work with, this is how you do it. So any part you're trying to create in CAD, whether it's a block or something like what I just showed you, it's really just a combination of 2D sketches that you make, and then you pull out 2D sketches to create 3D objects. So you can see here, I made a square, that's a sketch, and then I pulled it out into a block. And if you do that enough times, eventually you can pretty much make whatever object you want. There are ways to be clever about it, there are ways to not be clever about it, but that's pretty much all CAD involves. And there are some other features that you can add that don't involve sketches or anything, but that's the basic workflow. So to create our first part, what we will do is we will go up into the command window and we will hit extruded boss base, and we will get these guys. Don't click on anything yet because we'll talk about it. So as I mentioned, these are 2D sketches, so you need a plane to do your 2D sketch on. Anytime you start a part, it'll start with these 3 default planes, front, right, and top. So orient your part however you want to orient it, usually like how it's going to be built. So let's say we're doing the body tube, then we'll do our sketch on the top plane and extrude it up, because that's how the body tube is going to look when it's on the rocket. But yeah, so aside from these default planes, once you actually have 3D geometry, you can select the faces of those parts to start sketches on, and that's useful. And you can also make your own planes if you want to do like weird ones at angles or anything like that. So it doesn't really matter what you select. You can select the front plane for now. And the front plane will get you into your sketch window. And up at the top in the command window, you'll see it has automatically changed to the sketch pane. The sketch pane has just about everything you'll need to make your sketches. So when you're in the 3D environment, like we previously were, you'll be using a whole bunch of different tabs and stuff. But when you're making sketches, pretty much everything you need is right here. So in this window, there's all the tools for actually drawing your lines and stuff. So top left, there's the line tool. You can draw lines. Some of these have drop downs, so you can select different ones. Center line is dotted. We'll get into why it's dotted in a bit. Midpoint line, you can start in the middle rather than at the ends. That's useful for certain things. But circles, so center point circle, you can also drop it down and select points on the outside of the circle, and that'll get to a perimeter circle. Not terribly useful for right now, but you know, options. Splines are complex. We won't touch them. Center rectangles lets you draw rectangles in the center. You'll never guess what corner rectangles let you do, but they all kind of end up with the same thing. Similar to the circles, you can do arcs. You can do a center point arc. You just get a little half of a circle. You can do tangent arcs. So if you have a line already, you draw an arc and it'll always stay tangent to the line that you drew it to. That's useful. Honestly, those are the major ones. You'll have other ones like polygons, particularly if you're drawing like hex nuts and stuff like that. That's useful, but really just these four are going to make up the basis of most of your sketches. So what we'll do, let's draw a corner rectangle. Oh, and by the way, the keyboard shortcuts that I'm using right now have mostly just been escape. Will let you back out of something. So I've drawn that. If I just click again, I can draw another rectangle, and I can do this as many times as I want. To get out of it, you just hit escape, and then you're not drawing rectangles anymore. To highlight stuff, what I'm doing is if you click and drag from the left to the right, it'll highlight everything that is fully contained within your cursor or within this box. So just this line was fully contained. Like these lines, I had half of them contained, so they didn't get highlighted. If you drag the other way, anything that is even slightly within inside your box will get highlighted. So these get highlighted, press delete, get rid of them, whatever you want with them. Yeah, that's really all we're doing so far. So now we have a rectangle. You'll notice it's blue, which is the worst thing that anyone will ever do in CAD, because blue means that it's undefined. So if I were to extrude this into a part, then someone could come back and change this later, and I wouldn't know what dimension my part was. And that's not very useful for if we're going to be doing engineering, right? We want to know what size our parts are. So the way to do that, come up here, you have a smart dimension tool. You can also do all types of different dimensions, but smart dimension is nice because it will literally just choose the right dimension for whatever you're clicking on. So click that, gets highlighted, and you can come click on pretty much whatever you want. You can click on a line, and you'll see we get a vertical dimension. Set it whatever you want, set it to 2 inches. Solidworks is great because when you first draw something, when you set the first dimension, it just resizes the window to be the same as when you drew it. There are other CAD softwares where, like, if I put in 200 on this, then it would stay zoomed in to a really small distance. And that's really annoying, but Solidworks is helpful like this. So we have one dimension in here, and everything's still blue. So clearly it's still not defined. Well, we can see when we're clicking and dragging on anything, you can click and drag on lines, points, whatever you want to do. It's still moving around. So this line is not dimensioned. So let's put another one in here. Call that 2 as well. Now, still moving around, still blue, but it's not changing shape. So all that's left to do is actually fix it in place somewhere. So this is where we'll get into constraints, or relations, I guess, as SolidWorks calls them. You can already see a few of them here. So by default, if you draw a line that's close to vertical, SolidWorks will snap it to be vertical, and it'll apply a vertical constraint. If I drew it otherwise, now you can see I can make this line whatever angle I want. But still, if I drag it into a horizontal position, it'll snap to horizontal. The way constraint will not be applied. Because I do this as a box, it applied these vertical constraints for me right away, but you can click on them and get rid of them if you want to have weird shapes. The way to add them back is you click on whatever feature you're talking about, and it'll give you some options on the side here for horizontal or vertical, because I clicked on a line, and it's context specific. So you can select multiple things, which we'll get into in a sec, but we'll just reapply the vertical constraint here. That'll make sure this box is vertical. The one that we're going to use right now is the coincident constraint, and we're going to put this bottom point at the origin of our part. So the origin is the place where all three of those initial top, front, and right planes meet. So to do that, we click on this bottom point, and then if you hold Control, you can multi-select points. So you can say I have 2 points selected now, and I can make these points horizontal, vertical. So if it was horizontal, these points would just be on an imaginary line. Vertical, same thing. Or I'm going to choose coincident, and that'll move these points together. So now you can see all of this is black, so it's fully defined. You get a little notification in the bottom here that it is fully defined. And if you leave sketches not fully defined, that is terrible CAD practice, and you will be scolded for it. That's pretty much it. So obviously drawing a square is pretty basic. So we'll get into, I don't know that advanced is the right word, but something a little bit more interesting. And we'll try and make just a slot. So just with rounded corners. So easy way to do that, come in with a line tool, create a line, bring it this way, hit escape, come up to the arc tool, and we're going to drop down and hit tangent arc. Click on the end of this line, bring it up. So again, you'll see SolidWorks will create constraints that it thinks you want to make. So it thinks I want this to be a 180-degree arc. It'll snap it to right there. You can click that. Escape again, draw another line. Again, thinks I want to be horizontal or vertical of this point, which I do. It'll snap right there, and I can hit tangent arc again. And I get a slot. So a couple other things to note. When you have a closed section like this, it'll shade on the inside. So when we go to pull out or extrude this sketch, there needs to be a closed surface for the most part. If I were to say, what's going to break this? This is better than Creo. Yeah, so if I were to just remove this, then it's an open sketch. There's nothing that I'm going to extrude from here. I need to close it somehow. So close it with a line, you can close it with another arc, whatever. Also, it has added these tangent constraints because we use the tangent arc. If it didn't, click on one line, Control click on another, then tangents right there. You can set that constraint. Again, we're seeing some blue geometry, so just want to come in, dimension it, set it to whatever values you want for now. I totally intended to do this. So the other thing, you can define more dimensions than actually make sense. So this is not the greatest example. So to do this dimension, I clicked on this line and this line. if I clicked on this line and tried to dimension that, it gives me the same thing. It asks me if I wanted to make the dimensions driven. Basically, you can't over constrain your part. If you do, it yells at you, because obviously, well, these are the same, so it's true. But if I made this one, made one of these 4, doesn't let me edit it, but made one of them 4, then it would, that wouldn't make any sense. So while you do want to fully define your part, you don't want to over constrain it, because that can cause you issues too. So again, a good way to figure out what aspect of your parts needs dimensioning is just clicking and dragging on the points. And yeah, we will share this recording. And whatever axis it moves in, you know, okay, I need to add a dimension there. So we'll add another dimension. We'll get a square with a little blob coming off of it. So yeah, this is pretty much all you want to see when you've created a sketch, is a closed area, so shaded in the middle. And you can have things that are doubly shaded. So like I'll enclose I'll close this within another circle. So as there's, this part is still shaded, and I can choose when I go to extrude which area I want to pull out. So let's say I wanted to make like a circle with this cutout in the middle, and I can just choose to extrude this outside shaded area instead of the whole thing. But I'll do that for now. And yeah, you want to make sure that it is fully defined. So once you've done that, and you guys can mess around and create, you know, whatever shapes you want, however complicated you want to make it. But once you're done, you hit exit sketch. And because we clicked on extruded boss base in the features bar over here, it'll bring us right to the boss extrude feature. And all boss extrude is just, like I said, pulling a 2D sketch out into 3D. So we can set however far we want to pull it out. Right now, it doesn't matter. Like I said, we'll go more into turning these 2D sketches into 3D in the next meeting, but you can just choose whatever you want, and then you get a part. Other things, as far as, so now that we're in 3D, we can actually start to move around the window. So by default, the way to do this is if you have a middle mouse button, you can click that and hold it to rotate it. Or this is called orbiting your part. If you hold Control middle mouse button, this is pan. You can just move it in one axis. And if you hold Shift middle mouse button and you drag up and down, that is zoom. Also, you can zoom with the scroll button, like your scroll wheel, which is usually easier, but to each their own. Other things you can do with views is there are hotkeys for Control 1 through 8. And it just goes through the planes that are set up on the front. So Control 1 will do the front plane. Control 2 will also do the front plane, but this is the back view, and it'll show this in the bottom left corner, what view you're in if you're in a view. Control 3 left, right, top is 5. Miss Control 6. Control 7 will bring you to an isometric view, which is just like at an angle. And very useful for the next thing we're going to talk about, which is creating sketches on existing bodies. If you highlight a plane that's on a body, whether it's, I mean, you can do this with the front plane too. So instead of hitting Control 1 to do front, I can also select this plane and hit Control 8. And that brings you to a view that's normal of whatever plane you've selected. So let's say I want to look at this top plane, click it, Control 8, brings me right there. I'll try and find a like shortcuts cheat sheet guide for you guys too. I mean, like once you start messing around with it, it comes pretty easily, but just to have it on hand, it's useful. So what we'll do is we'll go over into the sketch toolbar, come up to the top left, make sketch, and then we can select top face or whatever face on your model that you have. You'll notice I'm still in this 3D view. I don't need to select anything because I'm in the sketch mode. If I just hit Control-8, it brings me to the normal view for the sketch that I'm working on. From here, again, you can pretty much just draw whatever you want. What we'll do is I'll show you how to project geometry into the sketch plane. So this is a really useful feature. Part of the trick of doing good CAD is having the parts that you make be easily changeable. So let's say I wanted to put just like a curved slot in here. There's stuff that I didn't show you. So like making this slot, there's actually a tool for making slots because it's a relatively common thing. That's right there. So I want to cut a little slot right in the middle of this part. Say I want to go to there and I want it to have some offset. But if I wanted to, like I want you to be someone like this, I want to be 3 inches. However big I made this from the edge of the part, and I want this to be 2 inches long or whatever. So the radius or whatever. And how far did I extrude this? I extruded this non-set distance. So this is a technically fine way to make this sketch. Like so I'll just hit this out and do this cut. You guys don't have to worry about what the cut is right now, but this is technically a fine way to do the sketch. So you'll notice it's fully defined. If it's not, there will be like a little minus sign in this icon. But let's say I'm looking at this part and I'm like, oh no, I actually want this to be 3 inches long. Relatively simple change. I make that change and now this slot doesn't go all the way to the end because I've set this dimension to be 3 inches to the end, and now it's 3 inches, or this is 4 inches now to the end. So a better way to do this would be to use the project tool, or the convert entities tool. What this will let you do is take existing geometry and turn it into lines on your current sketch. So you can see this face doesn't even touch the sketch plane that I'm working on. But if I'm looking at it from the sketch view, I can select that line that makes up that edge, and now I have a line here. And what I can do with this line is I can bring this point and I can set it to the midpoint of this line. We'll turn on some other things here. So you can see these dotted lines. I showed one to you earlier with the center line. Dotted lines don't make up a closed surface. So I can draw a box with these dotted lines or a triangle or whatever, and you can see it doesn't shade in because it's not enclosed. These are super useful for defining like things about your part. So the center rectangle tool, you'll notice if you make it, it comes with these 2 dotted lines in the middle. And let's say I want to make this a square. I can just select these 2 lines and apply a perpendicular constraint. Now I don't need to have like a 2-dimension here and a 2-dimension here if I want to make it the same. These are just now automatically the same dimension because these 2 lines are perpendicular. So construction lines are useful. You'll learn how to use them with more advanced parts than this, but so we'll turn this line into a construction line, this projected line that we made. Once you click on it, you'll have options to just set for construction. That way it won't interfere with anything. And let's say I want this to be 1 inch from the edge of this part. So I could define it to this point like I did, or I could define that to the actual edge of the part like that. See, so I don't even have to project some things. You can just click on them and it'll automatically put a relation in there. So now this little cut we did, I can come in and change this to whatever I want, and it accomplishes the same thing. So that's so that's how you use the convert entities tool. But it's really an exercise in this is how you do good CAD. Because if your CAD is hard, you come back to it and it's hard to edit, then that makes the life of whoever else is helping you on your part or whatever really, really difficult. So this is called design intent, like the whole idea behind making your parts such that they can be edited and such that they are parametric or that they can be changed with just one number. And it's really something that comes with experience, as a lot of Solidworks stuff does, or CAD stuff does. So don't worry if you are making parts now and you realize oh, I have to go back and redo this whole thing because I didn't set up the sketch this way in the first place. It's just part of the learning process. Yeah, so once you have that, that's pretty much everything you need to know for sketching. I guess the other thing is trim entities can be useful. So let's say I want to cut a square out of this side. So again, corner rectangle, we'll use the existing geometry to set this parts so it's locked at this point because I hovered it over when I clicked it. We can control select both of these two lines to hit equal, and that way it's a square, and set this to whatever dimension we want. Let's say instead of doing that, what I had done is do convert entities, and then I'd selected these two lines, and then I'd drawn my box like that, which is a fine way to do it. This is probably not the best example, but there are applications certainly where you need to do this. Now you'll see that this box isn't shaded because I have these lines that are extending past where this line ends. So the trim tool, you just click it and you drag, it'll give you a little line. Anything you drag it over will be deleted past an intersection point. So I can hover it over these two lines. This gets back to normal. Set this equal. Put it to 1 and cut that. So not a very useful part, in my eyes at least. I don't know, maybe someone can come up with something for it, but that's really the main things you'll be using for sketching. And this is basically the same tools that I'm using while sketching at my internship. So once you have these down, you're 90% done with learning how to do sketches. It's really just like I said, the design intent that takes a little bit of time to learn.
Can I ask what the difference is between driven and non-driven when you had that one error?
Oh, yes. So a non-driven dimension it's kind of a weird terminology. I've also seen it called as just dimensions and reference dimensions, which makes more sense. Basically, a driven dimension is something that is set by the existing geometry of the part, or something that is defined by another dimension. So if I were to put a dimension on this edge, for whatever reason, let me convert entities then. So if I do it on a projected surface, then it'll pop up and it'll say this dimension is a driven dimension, which just means that it's driven by another dimension. If this was actually telling me or allowing me to edit this, then I would be over defining my part. A non-driven dimension like this is just it's actually setting the dimension of the drawing that you're talking about. So for instance, I can right-click this and turn it into a driven dimension. And now you'll see, well, it goes gray. You can't really see, but now you'll see my part is back to how it was without the dimension. If I drag it, it just changes its value to whatever the new dimension is. And I can put in another dimension and say, for 1, 2 the same dimension, but only 1 is actually controlling the size of this box, so it's not overdefined. The usefulness for driven dimensions is usually in more complex parts where you'll be like just having a reference for what the distance between 2 objects are can sometimes be useful. Like if you're making a part for an assembly, you want to know what the distance between X and Y is because another part that you're building separately has to use that dimension. So it's just like a quick way to look at the dimensions that you're talking about.
So just to confirm, driven sets it in stone, or is that non-driven?
Non-driven is set in stone. Driven is controlled by something else. So like the dimension is driven by another dimension in this case. So this is the driven dimension. It is set by this dimension. I can't change this. That's not in control. But I can change this, which is non-driven. And then my driven dimension changes.
So if you make a sketch and then you do all these 3D things to it, you apply all these features, can you go back to the sketch and make it driven to edit the length so that every other feature is undefined? You showed it once when you edited that ring thing. You made one change to one of the first features items on the feature manager there on the left, and then that sort of had the ones below it undefined.
Yeah, so that's more to do with feature errors. Actually, I guess maybe it's a good learning thing. So the reason why that failed is because when I come up here and I add something else, so the normal way that I made this part is make that ring, make this cutout, pull out these panels, etc., etc. So if I come in here and I mess with that and I say like add a fillet, make it big. Now when I go to rebuild this part, it errors out because these sketches that I've drawn no longer have the references that previously exist. So that'll show up. So this is where I use the project tool to get this line. So now these are yellow because that line that I projected it off of no longer exists. There's probably an argument that this is poor design intent, but the reality is that like that's just a change that you would never make to the part. So you don't have to like make your whole sketch harden to adding a giant fillet because it doesn't really make sense for the geometry of the part. So that's why those error out. And then there are other things that just completely don't work. Like this is a warning. Like those sketch points aren't referenced off anything, but they're still there. The red things you'll see are errors where something has gone seriously wrong and that feature no longer exists. But
say you just wanted to change the diameter. Are you able to add a smart dimension, or would that be driven?
Yeah, so in that case, you wouldn't add another dimension because your diameter, assuming you've fully constrained your part, is set by something. So in my case, the diameter is set by this very first sketch. So I can come in here and I say, don't worry about the equation in there, but I want to make that 6 inches instead of 5.9. I hit exit sketch. You can see this part has design intent on it because that's a reasonable edit that you might want to make to it. And I can make that edit changing the very first thing that I ever did with this part, and that change propagates through the entire part without causing any errors.
Okay.
So that's what you want to be shooting for. There isn't really like you go in to make changes to a part and add another dimension, because if you're adding dimensions, then your part wasn't dimensioned well enough in the first place, is the whole thing. But yeah. Any questions about that or anything else we've talked about? Cool. I don't have anything else to say for today. This was really just getting started with sketching. I'll probably, like I said, I'll find a sheet for you guys to like keyboard shortcuts cheat sheet for SolidWorks, because there are a few that are useful. And I'll also send out an assignment. So what I've done in previous CAD workshops is send out engineering drawings. So this might be a little bit intimidating if you've never done SolidWorks before. So this is why I'll probably just say like make something that's around your house is a really good way to start sketching things. If I had my camera, I could show off to you, but basically just choose something that's around you at your desk, like make your laptop, say. That would be an interesting thing to do. And you can do it with the tools we learned here. So you could come in, you could do a rectangle. This is obviously wanted to mention this, but just for show's sake. You can do another rectangle on the front plane. You can put those guys together, and that is totally a laptop that any manufacturer would sell. I'd say it rivals Apple in its beauty, but just doing that is really going to help you learn how to use SolidWorks. And like I said, even with just the sketches and the extrude that we've learned so far, you can pretty much make whatever you want. I mean, I.E Minecraft, that is basically the exact same thing. Like it's a 2D thing, bring up squares, you can make whatever kind of shape you want. So there are obviously better ways to do it than in Minecraft, but it'll get you there for simple parts that you want to make. So I'll send out maybe some of these drawings if you guys want to. Some of you guys have used SolidWorks before or seen engineering drawings, want to try those out. Otherwise, I'll just say try making something. And if you have questions, feel free to put it in the Slack or send me a message to let me know. But yeah. Cool. Okay. Kirsten, you can probably stop recording.